Sir? Kumaran, sir?
Hello, ma'am.
Hello, sir. Good
Yes,
evening, sir.
ma'am. Good evening, ma'am.
Yes, sir.
Good evening,
Sir,
sir.
I'll give you
Good evening.
permission.
Good evening.
I made you as a
Ah,
presentee, sir. You
Yes,
can
yes,
share your
ma'am.
screen.
Yes, yes.
Madam, if you can make me
Ah,
also, it will be
yes, ma'am.
fine.
Yes, ma'am.
Thank you, ma'am.
Yes, ma'am. Done.
Yes, madam.
Ma'am?
Yes, ma'am.
Yes, ma'am.
Can we
I'll
start
just
the session?
I'll formally welcome, then I'll introduce you to invite ma'am. Yeah, very good evening, participants. Welcome you all for the day 5 of our 6-day online FDP on demystifying transformers, the brains behind generative AI. It's my privilege and honor to welcome our speaker, Dr. P. Kumaran sir, from NIT Puducherry, Karaikal. It's my pleasure to invite Dr. Anita ma'am, Professor, Department of SSC, Core VIT Vellore, to introduce our speaker of the day, Dr. Kumaran P. Over to you, ma'am.
Thank you, Agila ma'am, and welcome, Dr. Kumaran sir. I'm very happy to invite you to our audience. Before go ahead, I will be just informing you that our ATAL is happening for the past 4 days, and today is the fifth day. And today's session we will be having it as generative AI in education, and also followed by the LLM and the pre-trained models. So in this session one, I'm happy to invite our speaker, who is Dr. Kumaran P, who is currently working as assistant professor in Department of Computer Science and Engineering, National Institute of Technology, Puducherry, Karaikal, India, since August 2021. Before he joined this job, he worked as a postdoctoral fellow in Department of Computer Science and Engineering, NIT, Tiruchirappalli. Also, he was awarded by the PhD degree in the year 2019 from Anna University, Chennai, India, with the Central Government Fellowship. Also, he received his bachelor degree in the field of computer science and engineering and master degree in the field of network engineering from Anna University in the year 2011 and 2013, respectively. Also, he possessed the first rank and the second rank and received gold medal for both of his postgraduate and undergraduate degree in state level. Excellent, sir. I have more, and also he has more than 12 years of experience in teaching and research in various prestigious universities in India, like SRM University, Shastra University, and Welltech Multitech Engineering College. And also, his research area focuses on artificial intelligence and Internet of Things. And also, he has published more than 36 articles in reputed journals, and also has owned various international and national conference proceedings along with the various book chapters. And also, he is a member of IEEE and Springer IEEE, and also he is a lifetime member for International Association of Engineers and Institute of Scholars, India. So we welcome you, sir, for today's session. And I was very happy to say that participants, sir was also one of the resource person, which was the for the FDP, which was conducted internally by the VIT University. So his session will really give us much information regarding this generative AI in education. Happy learning and welcome you, sir. Thank you. Over to you.
Yeah, thank you, ma'am. Thank you so much for your intro. And so, thank you all. First of all, I should thank the organizing team because whenever if you are conducting any such activity, so identifying the resource person, that too, no, very difficult task. So thank you, by the way, for giving me the opportunity to be a part of this 6 days ATAL faculty development program. And I should also welcome all the faculty members, even though it is weekend and we have already worked from the morning. So after that, no, so we have committed for this. It means at least you will be you supposed to get something out of it by attending this workshop. So in that responsibility, no, I will be welcome you all, and I wanted to thank the organizing team and management for giving me this opportunity. So for the 6 days faculty development program on very emerging topic, so generative AI. I luckily got the opportunity to do the same topic workshop in the VIT long back, but it is the initial stage some 2 years back. But now, a lot of changes are happened. So again, I'm getting the chance to discuss my current understanding and work related to generative AI. So even some 3 months before, we conducted one workshop on generative AI in IIT Puducherry. So it's a great topic selections as a part of this FDP program. So I hope my slides are visible. So if you acknowledge, then I will proceed.
Yes, sir, it is visible.
Yeah, thank you so much. So I'll be taking the generative AI. Since we can apply for many application area, I specific to education. And but at the end only, I'm going to talk about in what way it could be helpful for the education. But before that, no, what basically these last 4 days you are getting much variations and a lot of information related to the generative AI. So to add up that, I will be giving my level of understanding about generative AI. And before we can go for that, it not basically the new topic, or even if maybe the idea is new, but always for all the thing we have some starting point. So it is not that one which is just invented. So we have already, the computation era and the AI era. So in that continuation, where it is added, or where it is uh, giving its contributions, that we will see. So first, with respect to this aspect, no, the 1930s first generation computer came into the world, but for India, we started using the computer from 1990 only. So almost some 50 years of gap. So even though the AI is the concept which came in 1950, later on there are a lot of evolutions. In 1980, it is categorized as subfield of machine learning, then 2010 subfield of deep learning. So in the right hand side, again, the evolution is still connecting the generative AI with respect to the AI universe. So again, it started with the AI. Later on, it is bifurcated to machine learning. Then neural network, one of the model in machine learning. Then from there again, deep learning evolution. Then finally the generative AI. So, so here one important point. Whenever we will be used to say that I'm working with AI models, then anything that are available below that AI, everything we can say in the superset level as the AI. Yes. So the same way we can identify here also. So if I using some model under neural network, you can call it as a AI model, because it is the again the subset of AI. So in that aspect, the generative AI, the task like text summarization or a text generation, so the transformer idea, everything, it's comes into that. So now, as the name suggests, what we are basically going to generate. There is a word with respect to the uh, uh, basic engineering. So whenever if the scenario comes, which is the basic engineering, I told in many workshops and FTP, oil, coils, oil. So oil is the representation of the civil, coil is the representation of mechanical, coil is representation of triple, and soil is the representation of civil. So oil, coil, soil. So that is the basic engineering, mechanical, civil, and triple E. So when it comes to CS department, as my perspective or most of the researcher perspective, data is our oil, coil, soil. So in that aspect, when I can say generative AI, what I'm basically going to generate, I can generate the data. So when I use the word again data, so data we have a many form. The data in the form of text, data in the form of image, video, and audio signal. So we have a many form. So now everything is possible. The answer is yes. So how you can able to further narrow down the generative AI for text generation? Generative AI for image, we can generate the image also. We can even generate the voice also. So it is possible with respect to the generic name of data. So now I will be having, since it is now possible for generation of all, I will be having a specific focus to one type of data, that is text data. So when I can use the word text data, then with respect to the text, we have already started our research long back under the domain is called as a natural language processing. So basically, the process of identifying the NDT, the process of performing translation, the process of performing the summarization, the process of performing generation, the process of analyzing the sentiment. So everything is comes under the umbrella of NLP. So when we even look at the NLP very close with respect to their evolution, so in 1950 to 1980, so the NLP, it is there in the market. Later on, the deep learning integrated with the NLP after 2000. Then after 2017, the transformer models are integrated along with the NLP task. Then we can see the further growth of ChatGPT followed by the current version of GPT-3, GPT-4, and other models by the other firm. So this is how we can see the evolutions of NLP. So what is my point is when even we wanted to very closely look at the publishers, what is their recent trend when we can look at in this aspect? When you wanted to identify most of the journal and their publication in 2010, most of them are related to Internet of Things. And if you closely look at in 2013 to 2016, you can see many publications related to big data analytics. And after 2017, you can see many papers are related to deep learning. Then after 2020, you can see many papers are related to this transformer. And even in between, the edge and fog computing related papers are more demand. So what is the conclusion is, if you look at the NLP aspect, if someone who are the scientist under natural language processing task, there is no there is update, but there is no end, because since 1915 to till date, almost 75 years, the different transformations still it is exist, because it is one of the unavoidable form of data. So the data in any form, so it is one of the unavoidable form of data. So the conclusion is that we have a life always when we are dealing with the text data. So that is the primary aspect. So I'm also did my research also related to text data. So I will be taking the generation of the text is the primary objective for today's discussion. And when that we wanted to look at further with respect to understanding, even though we have a many tasks related to text, before that we wanted to understand one quick things related to the transformation of the word algorithms. The classical algorithm having the nature of the receiving data and the rules supposed to be informed by us. Then it has to give the corresponding results. But the learning algorithm having the variations. So that is what the learning algorithm having a separate subset in the traditional data mining also. So the data mining data warehouse is the we are already first familiar with respect to this data learning or the learning based group or learning based type. In that, the learning algorithms are no separate one which has further bifurcated or divided from the data mining and warehousing, that is machine learning. So basically, the learning algorithm having different in nature. So the data and answer we supposed to give, it's supposed to come up with the rules. So that's how the changes happen with respect to computing. So now, since I told I will be focusing towards the uh, text, so that is NLP. As I have shown in one of the slide about the different NLP tasks. So which I wanted to focus. So because we have a many tasks to do. Say for example, we can do in this image one of the text to text transformer, DeepI transformer. We can do something is called as a summarization. We can do something is called as the sentiment analysis. We can do something is called as a translation. So everything is one of the task or the task of NLP. But here the even by even I will narrow down. Under NLP, even though we have a many tasks to do, I will be having a focus towards text generations. Basically, the text generation comes under the casual language modeling. So what is the idea is we need to give a piece of text, it has to complete the text, or we have to give a complete text. With that complete text, it has to generate a further text. So incomplete text supposed to be completed, or the complete text with that reference, it has to further give information related to the text. So both the cases are comes under the category of text generation only. So as I have highlighted in the third point, either you wanted to complete the incomplete sentence or you have to generate the new sentence in the next line. Both the cases which will be coming into the text generation category. So these are all the popular models are available in the market. So GPT having the different models in it to do the same task, and Google having the Palm family, Meta having the Llama. So we have many things in the market to do this task. So here I wanted to give you one more clarity. So the text generation is the one keyword. So we have something is called as a text to text generations. So both are completely different. So the text to text generations will having the operations which I have listed here. And as per the transformer aspect, yeah, how it could be differentiated, the text generation is purely the decoder only architecture, and the text to text generation is the both encoder and decoder architecture. So both you will get a clarity. It means the text generation is a left to right operation, and the text to text generation is the right to left operation. Both the operations are there. So so that is basically the difference. So again, why I have even brought the text to text generation is, say for example, whether I'm going to do a question answering, whether I'm going to perform a translation, or whether I'm going to perform a summarization. Of course not. This is the text to text generation. My focus is related to only text generation. So that is the proper bifurcations. So in this scenario, if you look at, I have asked the questions and it has to tell the answer. It's supposed to read entire questions left to right, and again right to left, understand the context. Accordingly, it has to answer. Likewise, if I want to summarize, if I wanted to translate from one language to other languages. So this is the text to text generations. So here our focus is simple text generations. So now the narrow down is that generative AI, there will be a focus on data, that to especially focus on the text data. And even though there are many operations under the text data, we will be having a specific focus for text generation alone. Fine. Now, before we wanted to go further with respect to how basically a text generation works in the generative AI, one important thing what we wanted to keep it in our mind is everything what we are expected, whether we wanted to expect it to do a text generation, where we are expecting is from computer. And one important thing with respect to the human being and computer, whenever we are look at any scenario or problem in the real world, we are interpreted that scenario in terms of physics aspect. Whenever if the object is moving, whenever if the object is jumping, or whenever if the object is changing from one state to other state, everything we are witnessing, everything we are taking in terms of physics aspect. But the computer is totally different. Whatever you are taking, change of color or movement of object, everything that machines or computer is supposed to be understand only in the format of mathematics. So that is another important point. Everything is math for computer. Everything is number for computer. That is the whole point. So now, why basically, why we actually have this discussion is the human is physics and computer is maths. Is even though if it is a text, that's supposed to be no understand by the computer in terms of numbers only. So this is a very basic thing which wanted to know whether if it is a text that's supposed to be converted to a number. When we wanted to do this task, we have different method to do that, as well as there is evolutions of that also. So say for example, if there is a word as shown here, like a king, queen, man, woman, child, the computer cannot understand everything. It's supposed to be represented in terms of number. like the number that are represented in the left hand side. If you wanted to represent queen, you can represent like a 01000. If you wanted to represent the man, you can represent 00100. If you wanted to represent the child, you can represent 00001. So what is that idea is, this is, we know that one hot encoding. Now I'm not coming to that whether I'm doing the encoding or right hand side, the example is embedding. So I'm not talking about whether it's encoding or embedding. First level is it's supposed to be converted to number. So first thing. So when I wanted to do that, it's supposed to be converted to number. Before I wanted to convert that into a number, which one, especially the text. The texts are there not in the form of just like separate words. It is supposed to be collections of sentences. So first task, what we are expected as a part of the text is we have to perform the tokenization first. And the word supposed to be no extracted from the sentence. The sentence supposed to be extracted from the paragraph. The paragraph supposed to be extracted from the document. So we need to do that. The individual word supposed to be extracted. The process is called as the tokenization. Once it is done, then we have to assign the number for the individual token. And when I can come to that, assigning a number or converting a word into a number are basically called as a word to vector. Then we have a methods. First, we will be going with the encoding method. Then we will be going with the embedding method. So what is the difference among encoding and embedding, and which will be preferable? Everything we can see. But before that, when we can coming into a tokenization, basically we will be having the tokenization like character level tokenization and word level tokenization. So someone is unmuted. So I kindly request to mute. Otherwise, the coordinator, please kindly mute all. If
Yes, sir.
they
Yes, sir.
are.
I'm doing. One second, sir. I'm doing.
Yes.
Yeah. Yeah, you unmute and you proceed, sir. Sir, you have to unmute, sir.
Okay, fine. So the idea is the basic word level. You can separate from one word to other word based on the space or based on any special symbol or based on some rule. That is fine. But here I wanted to go for the special tokenization that are no very much needed as an aspect of generative AI is the subword tokenization. So the single word again bifurcated into a multiple word in it, and each word having the separate number. So that is the concept of subword tokenization. So to do that, we have a many method like a byte pair encoding, word piece, unigram, sentence piece. So these are all the further important things that we wanted to look at. Say, for example, the first level tokenization, if any texts are there, that's supposed to be splitted into a word. And if sentence are there, supposed to be splitted into a word. So this is an example of character level, word level. But what is meant by subword level? Say, for example, tokenization. If I keep the tokenization as such, then it is called as a word level. Then token separately, icing separately, then it is called as a subword level. So this is the task is performed in the transformer as well. No, the generative transformer based generative AI models. So so these are all the basic way of doing. So now coming to that, the subword. So can we do that the subword for all the words? The answer is no. So that is the first thing we wanted to understand about the subword tokenization. So the frequently used word you cannot able to bifurcate. So there are word which is rarely used. So you have to think of those words to be split into subword. So here we have, but rare words should be decomposed into meaningful subword. That is the primary objective of subword. And why again we wanted to do that is any NLP related task you wanted to do, you basically need something is called as dictionary, or we will use something is called as vocabulary set. Say for example, if you wanted to do any sentiment analysis, how basically you will do if you have a line of 10 words, and what is the sentiment of that sentence? If you are asking, Then again, as I told, the computer is the consent. The words are not interpreted directly by the computer. All 10 words supposed to assign with some numbers. So if that number related to the concept of sentiment analysis, so it should have some subjectivity value. It should have some polarity. Based on that only, I can able to identify whether the sentence is positive or negative. But before that, the words that are available in the sentence, where if I'm having subjectivity value as well as a polarity, where I supposed to keep this value? I supposed to keep that value into the dictionary or vocabulary. And another important point is, what is the size of the dictionary? What is the size of the vocabulary? Should I able to keep all the English word? Then it is the question mark, because the language, it is evolving language. Even if you have noticed recently in Instagram, the current generations are using some of the English word which are not available at all. After 2010, there are many words that current Gen X people are using, and that words are not available earlier. That is English words. So this is also the reason that why we are not using natural languages as the programming language to communicate with the computer. We are not using natural languages because of the natural languages are infinite in nature. Also, we have another important reason that natural languages are having ambiguity. The same word having different meaning with respect to the situations. So these are all the basic influences or basic understanding with respect to the natural languages. So coming to this, so there are the unfamiliar words supposed to be recognized, and it has to be used as the subword to increase the vocabulary size. So in that aspect, the byte pair encoding is one of the mechanism that is introduced in 2015. The earlier GPT-2 and Roberta models are used this byte pair encoding mechanisms only. So what it will basically do is it has to build the vocabulary. First, it is having some basic vocabulary, then it has to add the words into the vocabulary, and it is having the size also. So how it basically do? It has to take the word and it has to check the concept of something is called as a merging, and the base vocabulary is already available. Then from the available base vocabulary, it will identify the words are having more number of time. That is, the concept is called as a frequency. Based on that, it has to merge two word and put it into the vocabulary. So the merging will continue till that the maximum vocabulary size reach. Say for example, here there are 5 words are there, and the number of time the words are available, the frequency value also there. From there, the unique words are extracted, and it is put it into the base vocabulary. Then I wanted to extend the vocabulary. So what basically do is, among this word, the words are split into a character, and I just look at that the combination of the character, how many number of time it occurs. That is frequency. Say for example, U and G available in this example 10 times, here 5 times 15, and here 5 times 20. Compared to the other combo, this one will have more number of times. So I will be adding U and G into the vocabulary. Then after adding with the available result, I have to check the next higher frequency of the combinations. That is what we will call as a merging. So this is how we will be extending the vocabulary. So what is the statistic says that is the GPT-2, the vocabulary size is 40,478. That is overall vocabulary size. Whether that all 40,478 as the base, the answer is no. Only 478 are the base character. The remaining 40,000s are no come up with the merging only. The same for GPT-2, 50,257. Among that, 256 as the base and one is the end token. Remaining 50,000s are evolved in by performing the operation is called as a merging only. So here we have a statistical proof of what is the total size, and when we are removing the end of the text, what is the remaining total vocabulary size. So this is the base. Even if you wanted to do the NLP application, or if you wanted to do, say for example, you wanted to do the text generation for one specific medical application, like Siddha applications you wanted to do. So what is that idea is, if they are giving symptoms, Upon reading the symptoms, you have to give the medicine for that. You have to give the procedure to consume the medicine. Then you have to derive the description by yourself. You can build the model. By the way, when you wanted to do that for this specific applications, then the medicine names and the procedure to consume the medicines are completely unique. So now what you're supposed to do, you have to collect the base vocabulary with respect to the particular applications. Then you have to come up with the result of that. So what I told is basically one research, generative AI for Ayurvedic or Siddha prescription writing. You can do like that. The other way, say for example, I will give you another scenario. Say for example, with respect to the exam aspect for the students, before they wanted to go for the exam, they have selected some 20, 30 topics to study. And they are not having interest as well as time to study all the text and reference book. So they will be going for ChatGPT or any online resources to type their topics they wanted to study and get that info and proceed further. But the important point is whether the information what they got is right or wrong. They are not having much understanding of that, because even for a ChatGPT also, yes, now it is upgraded with a lot of internet data. But even if you see that it is working fine, but the earlier researchers as well as teachers still they have a feel that it is good provided that we will be giving a right data or it will take the right data. If it will take any garbage data, then it will be come up with a result like garbage in, garbage out, rather than the right input. So still they will be having a doubt with respect to the source of the data. So coming to the objective. So what here we have still the question is whether the data are taken from the right resources, whether the information is available are right or wrong. If you have any such doubt, then you can build your own generative model where you can give input from the multiple text and references book of any subjects. For data structure, you have identified some 15 books. You give all the text and references book as the input, then you can expect to generate the text from out of it. Then you can relay that text because it no other input, only the inputs are available on the so reliable sources of text and references book. So what is the conclusion here is we can make use of such kind of applications with respect to this generative AI concept. So now the thing is tokenization is the one, especially for a subbird. What I have told is the byte pair encoding, but it is not only that available in the market. We have many such models, but the working mechanism is different. So another thing is called as a word piece. The BERT and a digital BERT or Electra are used this model only for performing tokenization. So the approach is completely a probabilistic approach. So one I took one example from the internet to give that clarity. Again, the words are taken and their frequencies also updated parallelly. And now we will be split individual data, and we wanted to see the pair, how often this word followed by this word comes together. So we have to look at the pair. So the pair score are calculated based on the probability of that. So the individual probability followed by the togetherness probability for H and U. For this example, it is come up with a pair score of 0.25. The same supposed to be computed for all the pair. It is not for only H and U followed by G followed by G followed by I followed by N followed by G followed by F. So two words will be taken as one pair, and for all that pair score will be calculated. And finally, it has to compare among all the pair, and which will be having the more pair score that will be added along with their base vocabulary. So this is how again they will be building their corpus. So again, this process continues to do these tokenizations or fill up the base vocabulary. So another approach is called as a unigram approach. So here also we will be having a mechanism to do the same. I mean, it is completely some different mechanisms. The total number of vocabulary available, how many time of H is available, and here we have another mechanisms to do some computations and come up with the results of how basically the things are built. So with that, the conclusion is these are all the different mechanisms. But what we have to understand, the first thing is whenever we are dealing with the text is whether the words are separated or the words are extracted from the sentence or not. Yes, once you have done that, then the first thing is over. Then we will be coming to the primary objective, that is converting or giving a number for the individual words. So now when we can coming into this aspect, giving a number to the words, then the first or earlier mechanism is called as one hot or one hot encoding mechanism. It is basic encoding is the first thing. So what we will do is um, if we wanted to represent one word, then it has to be, if we wanted to represent the sample word, then everything we have to put one remaining zero. Otherwise, we wanted to identify which word currently your individual number we have to give, right? D, you wanted to give a number, that alone will be put one, remaining should be zero. Likewise, the individual word will be identified by where we have a one. So then we can look at this aspect. What if the dictionary size is increased? Then of course, giving if 20 words are there, then you have to give 20 lines of input for that. So it is not that successful, but this is how we have identified the evolution. Otherwise, we can go for index-based encoding. This is another method. So what we can do with this is individual word have some unique number. And if you wanted to identify any word, then that unique number will be assigned. Again, here also the question is what if the size of the words are increased? Of course, we will be having always that constraint. But one important point what we wanted to notice here is each words are identified with a number. But when I wanted to put forth the other scenario, say for example, from one word to other word, if I wanted to identify some relationship or the technical word is called as a semantic meaning, then I cannot be able to done with the encoding mechanism because with by looking at the number alone, nowhere I can say that this number and this number words are very similar topic number or similar meaning number. I cannot have any reference out of it. So what we are going to do is we will be going for the another mechanisms. The another mechanism also the objective is same, giving the number for the word. But now rather than giving a number just like a single number, we will be giving a number with respect to the different features. So the idea is, what is the idea is from one word to other word, I can able to identify what relationship it is. So that is what we will call as a semantic meaning. How we can able to do is, first we have to extract with a set of linguistic features. This is how the concept of features coming into the picture. And the feature is the concept whether we will be using for a basic data set, image, feature extraction, video, feature extraction, because we are, if we are using machine learning or deep learning, everything will be looked at into the rows and columns. So features is the keyword for us. Here also the linguistic meanings are linguistic features. So for these words, I can have some linguistic features and then I will be assigning some number related to that particular feature for the particular word. With that, I will be having some interpretation that by looking at the features value, whether these two words are similar words or dissimilar words. Say for example, king, queen, princess, along with the woman. When I can see the royalty, I can see here the more value than that. So then these three are belongs to one group. Or when you project this into the graph, then you can see that all three words are supposed to be closer to that compared to the woman. This is how we can see that these words are similar word, these words are in dissimilar word. Again, this idea we will be going to use for the next topic also, because the idea of the topic is, yes, one word to other word I wanted to identify whether it is equal word or not equal word, or similar word or dissimilar word, or the semantically equal meaning word or not. That is the primary objective. Whether that objective is going to pay anything, of course it will be going to pay many things. We will see one by one what way it will be helpful. Before I can go for that, as I have highlighted for the tokenization, whether what all the mechanisms of tokenizations are there and which will be primary focus, the same way the embedding also we have a mechanisms. So one thing which I wanted to know learned from my supervisor, and the same which I wanted to know express in this forum, it will be one approach that we used or that has been imposed by my supervisor. any topic, if you wanted to do or your students wanted to do a research, the first thing you can ask your students to come up with what is the domain which you wanted to do a research, what is the current hierarchy of research for that domain, in what are all the different way that research domains are happened. So like this diagram, if you want to do some novelty in word embedding techniques, what is currently available word embedding techniques are, come up with the hierarchy of that. There you can think of no whether you can give contributions to already existing mechanism, or you can able to introduce a new mechanisms. Everything we can do so that with this way of this will be give a better understanding to do the research where it is really need the research, where we have really the gap. And one more aspect that I wanted to highlight is in system to do, again, it is a suggestion. Since you are all our faculty, you know that how to do the research. I don't want to give any input, but again, this is the forum I will be sharing. Request them to do a survey paper before they can go for any implementation. The survey paper is the one will give them the very the clear cut clarity that where they wanted to really focus on. Because if they are publishing a paper or if they are going for the final viva voice, whatever the direction question comes, they will be very clear that no, I will be focusing only to this directions. I have not gone through in that way. I will be noting down. I have never thought of it, but I will be very clear with that with respect to this way of doing this. This is the best method. So they will be having better clarity. So now coming to this again, so since we have these are all the way to do the embedding, so again it will take more time if I'm explaining the each and everything. But yes, the embedding is no to have the flavor of semantic relationship. It is not there in coding. That is the one thing. So now I will take you. Still, we I have to discuss more things to do that. So now the objective is yes, any word that are converted to number I have done. Whether if I'm doing with encoding method or embedding method, but I have a number in my hand. So what is the next step is with that number, we wanted to go for the generation of the text. So now how directly, that's all. We don't have anything to do. No, yes, we wanted to look at one more aspect. Whether the generation of the text, the number is there, right? So whatever the mechanisms you will be using or method are using, the first step is converted to number. Yes, I have done that. So now what is the next question is, the generation of the text is a very recent mechanism, or as I have shown in the first diagram, that generative AI is the one which is going to generate the text, image, video, audio. Yes, fine, but it is the first thing. Whether we are not aware of that text generation keyword earlier, the answer is no. We have already the strong background for the text generation, and it is the evolving stage. So that is also very important. So I will be even touching all that how basically it is started and what are all the earlier mechanisms we have, then how it's supposed to be do this task currently. So that should be the proper understanding of any particular topic from scratch. So before I can go for that, the large language model, as we are aware of it, with respect to text aspect. And when we can go for the image aspect, text generation, large language model, and image generation, both are comes under generative AI only. Generative AI, text, LLM, and image. Then what is that? We have something is called as a diffusion model. So when the diffusion model comes, it will be going to the image generation. When the large language model comes, then it will come to the text generations. So to connect that, I brought the clarity of LLM. So again, as I have highlighted, we can do many text-related tasks, but here the primary focus among that 8 samples are noted here. Primary focus is on text generation. So what basically a text generation, what LLM will do, say for example, if you have a word something like this, incomplete word, then you have to predict the next word, whether it's supposed to be once upon a time or once upon a tiger. So that is the basically the text generation. So here also we have no proper statistics as well as the evolution of a large language model, how it came, and others are how they are doing in the market. So this is a one source of large language model, and the different entities are part of this large language model in the market. So coming to that, before I wanted to go for the large language model, what is the idea? Again, before the large language model comes, we are also aware of the encoding and decoding approach. What is that basically encoding decoding approach? As the example we have taken once upon a time. So when you are thinking to do a neural network to predict the next word, like once upon is the next word, upon is the input, is the next word, then time. So this is how if you are expected to do. Imagine that if you are having some 15,000 vocabulary and each one will have a direct connection with 50,000 word in the output. So basically it is a 2.5 billion connections. And if you have a three words, say for example, once, then upon will be predicted. Then upon is the input. Time will be predicted. So followed by time. So if you can see that three times you wanted to repeat. So three times means basically 50,000 into three. So individual 1,50,000 input will be connected with the 50,000 output. So it is basically a 7.5 billion connections. Say, for example, now we are bringing the clarity of the semantic meaning, that is the word which were used under embedding. Say, for example, there are three words, the king sat on the, quick sat on the, and princess sat on the. If you know that king, queen, and princess are relatively a similar word, then of course we know that the answer should be thrown. And so what we supposed to do is when the king, queen, princess are belongs to the similar word, then we no need to have a separate connection. Instead of that, we can connect all three into one single connection. So rather than we are having the separate connections. So when I can say all three belongs to a single connection, then we are bringing the word is called as a encoder and decoder. So what is that idea is we will be having collections of word and identify their group. Rather than connecting 50,000 output, we will be connecting some in between nodes. Say for example, some 256 nodes we are connecting. Then if you are doing this calculation for so 256 only we are connecting, not all 50,000. The same way, the 256 only will be connected with the 50,000s of output node. That part is called as a decoder. When you look at the whole structure, instead of connecting 50,000 with the 50,000, 50,000 with the 256 encoder, and if you say this encoder, it is having the connections with multiple thing can be represented with a single data. So that if the king sat on the, quick sat on the, and princess sat on the, throne will be getting the result. So in that aspect, we are looking the numbering aspect or the number of connection. 50,000 into 256 for encoding, 256 into 50,000 for decoding. So it is basically 25.6 million parameters only. And if you wanted to look for three words, then it will become as a 76.8 million parameter. So if you look at the same scenario, when we have a 7.5 billion, here we are restricted only in millions only. So with that, the conclusion is the importance of bringing the encoder and decoder architecture and how it is important. Hello? Yes? Sir, வீட்டுக்கு வந்துடுங்களா சார்? B12 சார், B12. நான் ஒரு மீட்டிங்ல இருக்கேன், நீங்க காலிங் பில் அடிங்க, அங்க வைஃப் பண்ண முடியும். ஓகே. செகண்ட் சார், செகண்ட்ல ஆமா சார், செகண்ட் பிளாக். So as I told you before, the semantic meaning, now how that semantic meaning are giving the clarity with respect to the encoding, decoding. So now next, as I told you earlier, the text generation is not new for us. So these are all some of the way we can see that our text generation, we are typing, it is suggesting the next word, fine. But we have done this for long back. So the probabilistic based language model, we started there also we have done the text generation, and I will show what all the methods are there. Then we have done the text generation by using neural networks also. The RNN, LSTM, GRU, all are used for text generation, character generation. Later on, the transformer-based language model for text generations. The current text generation models are transformer-based. So before itself, we have done the text generation. When you can closely look at with respect to a probabilistic model, the N-gram model, hidden Markov models are even perform the same. Even if you have looked at the research article in 2010, 2011, 2012 for the text generation task, because I started my research in 2015, and if I have gone through the research article before 5 years, I can see many papers are performing NLP tasks using this N-gram approach, hidden Markov model. Then later on, from 2015 to 20, I can see many such tasks are executed by neural network model. Now we can see that last 2 3 years, we can many articles to do the same task using the transformer model. So what I wanted to look at any task or any applications, you can see how basically the evolution happened. What basically the starting point and how it goes gradually, then what is the current state. So this is very important when we wanted to strengthen our research. Why I'll be always focusing on that is this might be helpful and this might be same for all the scenario. When we are started with one approach and later on we are transformed to many ways, then again definitely there will be a point that we have to start or using the same mechanisms what we have used earlier. But if you are not aware of what has been used earlier, then it will be very difficult to come up with the next evolution, because always I can see that anything will be a circle. There is a starting point. After going long, it has to come back to the same point. So one example is our biometric applications. Earlier, we will be using a thumb impression by using ink. Later on, we are told that the signature should be a unique identity. Then again, we are come back to that thumb only, but in the updated form. But before that, you should have a clarity that how basically thumb works, how that the features of the thumbs are extracted. Then only that the biometric concept came into the picture. So this is how I always insist that any domain, if you wanted to expertise from the beginning to end, you should have the clarity. And now there is one more aspect also. So in 1930, we have our theoretical computer in our hand, Turing machine. 1940, the first generation computer came into the market with the inspiration of Turing machine. And now almost 85 years, we will be using the computer. And next, the world is looking for the next evolution of computer, that is a quantum machine. When we can look at the quantum computing, quantum communication, let's put that communication aside. Let's put at the computing, as the government also expected for the quantum algorithms. It is not a quantum machine learning algorithm or deep learning algorithm. Quantum algorithms, as how we have studied many algorithms in the design and analysis of algorithm subject and data structures, and we have evaluated that time and space complexity of the computer with the algorithm. The same way they are expecting to build your own algorithm that should run on actual quantum machine. It is not the algorithm that are run, since the quantum machine is not practically there, I will be doing it on the analog model or circuit model. No, it is not that. Actually, you have to run in the quantum machine and you have to build the algorithm for the quantum machine. Again, when we wanted to do such things, we have to go back to that what is the internal architecture of the quantum machine is, as we have a motherboard, as we have the very further level of the gate, the transistor. The same way we have to go in that level deeper for to understand the architecture of the quantum machine. What is there inside? What are all the things are there? Whether still it is there in the format of a RAM and storage. So the same. Then we have to think of the time space complexity inside the RAM, inside the room. So very soon we will be having the another computing available in the market. So to understand that and to become an expert, we have to again should know all the basics. the basics that we have followed in 1940 to generate that computer, the same basics might be useful or might needed. But we get to know that after some 5 years or 10 years, every computer replaced with a quantum machine, then we supposed to design a different curriculum syllabus, and we supposed to learn also. So coming to that aspect, the probabilistic based model, say for example, if I take an n-gram model, if I have given some word like I have a dream, then I supposed to no, predict the next word. Or if I have given the word like have a dream, or I have given the word like I have alone, the next word I supposed to predict. Say for example, I have is already available word. What is the next word? So again, if I'm predicting the next word, it is not just that the dream is the only option. I have again the concept of vocabulary. Among the vocabulary, I can able to see that have is the possible input earlier, then what would be the possible output next to that, and which will be having the higher probability, that will be as the predicted word. So that is the basic clarity, right? Basic idea. Say for example, this is the basic corpus, and I have the word is called as this is the. Then I have to look at the this is the followed by what are all the options are there. This is followed by house may be the option. This is the followed by rat may be the option. This is the followed by dit may be the option. This is the followed by a malt may be the option. So I wanted to predict the probability. So how basically the probability, basic probability clarity. So now what we are supposed to do, this is the available in the whole sentence 4 times. In that, this is the followed by house will be available 1 time. So the same way I wanted to do the computation for all the word, and which will be having the higher probability, that will be the predicted word or suggested word. So again, we will be having a word is called as a gram. So if I'm giving a 3 word, I'm predicting the 4th word. I will be giving a 2 word, predicting the 3rd word. I'll be giving 1 word, predicting the next word. Likewise, the concept of n-gram word coming into the picture. Say for example, this is the house. So then 3 words are given and 4th words are predicted. Then it is 4-gram model, and 2 words are given. 1 word are given. Second word you wanted to predict. Then it is called as a bigram. 2 words are given. 3rd word you wanted to predict. Then it is called as a trigram. So this is how the gram n-gram approach works. So now I will be show one more example here. Say for example, again this is another corpus. As the 3 gram, the 2 words are already given. I wanted to predict the 3rd word, so I will be checking the probability with all the words. So that is what my basic vocabulary. So the girl followed by next, the girl followed by next word. Likewise, this computation is done for all the word. Then I can see that the probability with respect to only 2 words. One is bought, another one is applied. Then I have to decide which word I supposed to go for it. But one important thing what we have noticed is we will be always, we will be just going for the next word based on the corpus. The corpus, or the combination of word, or the how often that next word coming into the corpus, that only will be the mechanism used here to do that. So, and also another important point is when we have the long range word, the long range word dependencies are not considered into the picture. The semantics is not at all considered into the picture, because even though if the bot will be the word will be available more number of time in the corpus, why should not I select the played? Because I don't have any, I can select, but I don't have any mechanism to do that. I have not analyzed any word. I simply, with the available of corpus, I went with that. So what is the idea is why actually we are in the demand of moving from one mechanism to other mechanism. So in that aspect, I have listed some limitations. So then the neural network based language model came into the picture, and it is having their own mechanism and justification for performing the operation of text generation. So as we know that the 2 models, one is recurrent neural network, another one is long short-term memory. Uh, Basically, what idea of the RNN is there is something is called as loop, so recurrent process. So how we can able to interpret is, say for example, uh, when I will be giving the old data, and from that I will be predicting the next data. Then next data will be given as again as the input to the current data. Say, for example, if I wanted to predict some situation of tomorrow, then I will be giving yesterday data and I will be come up with the result. Then with that result, I will be giving today data. Then I will be predicting the tomorrow data. So basically, which is something like this. So again, I have taken one example from the internet to better understanding the RNN. So if I have some interpretations like this in the bottom, like if I have the prediction of stock market, yesterday it is low and today also low and predicted that tomorrow should be low. The same way, yesterday low, tomorrow medium, and it will be predicted, sorry, yesterday low, today medium, then tomorrow it is predicted as high. Likewise, yesterday high, tomorrow medium, then it is predicted as low. Likewise, yesterday and today it is high, predicted as tomorrow high. In that aspect, so we have some small neural network here, and we have an input and corresponding weight, and we have the activation function. Then we will be predicting from yesterday to today. Then the results again will be fed because today data is not our interpretation. We have already our today data. So the results of the today will be given to predict the tomorrow data. So the step-by-step procedure of how this basic small neural network works to this problem. Step by step it is highlighted, and we have the many online material also to do that. So just for understanding of the recurrent neural network, I took this. And so this is the idea of what is the concept of loop comes. So if I'm predicting the today data, it is not my important thing. So then I will be feeding that to the next layer, and I will be come up with the result of tomorrow data. So this unrolling only will finally come up with the architecture like this. So day before yesterday data, and I will be getting yesterday data. So that is not predicted objective. The activation function result is again given to the yesterday data. Yesterday will be given along with the today data. Then I will be predicting the tomorrow data. So this structure is called as a recursive or recurrent neural network name. So now it is not that we can think of many activation function in between that, but we have two important problem as a part of recurrent neural network. That is again the reason why we wanted to go for LSTM. So the two, before I can go for the reasons for what is the problem with the RNN, we can do not only the text generation, even character generations are possible in the RNN. Say, for example, if the T is the word is given, predicted what is the next word, then next word is input and predict the next word. Next word is the input, predict the next word. That also possible in the RNN, or even we can give an individual word and we can predict that word also. So in this example, again, the idea is when we have a word, then word cannot be taken as an input. That's supposed to be converted to number. If you are going a number like encoding, then again, no, the vocabulary size is increased. Then we cannot have that many number, as well as there is no semantic concept. So what we will be going is better. We will be going with the semantic features. So these are all the word, and these are all the linguistic features. We will be giving value for the feature, and then that the vector will be given as an input to the model to interpret individual one. Say, for example, if I can say country, the Cummings and Tony comes under the number. So it is like both are a person. A country, Australia is a country, remaining is not having the value. So this is how we can see that the semantic meaning of the word. So now what is the problem is there are two problems. One is vanishing gradient problem, another one is exploding gradient problem. So most of them are aware of this, because when I can say neural network, the important aspect is the parameter. So any model, if you take as the word of machine learning, what we are closely observe is model means combination of two information. One is the parameter, another one is the variable. The variable you can take it from the input data set, but parameter we need to fine tune. In that aspect, the neural network, the parameters are weight and biases. So initially always we'll be going with a random, then later on we need to adjust and update. So in that, one of the mechanisms called as the gradient. So, but when we wanted to come to that the gradient and the optimal value for individual weight, we will not get that optimum. Sometime no, we know that when we have long way from the global minima, then it should take a maximum step closer, then take a small step. So it is not happening with respect to the RN. That is a reason there is a movement for the LSTM, as well as the long-term bird and their dependencies are not considered. So even to consider both the cases, we have moved to LSTM. Again, if we are look at this aspect, the clouds are in the sky. That is the expected word. Then if you look at this scenario, I have been studying in Spain for the last 10 years. So I can speak fluent. If I wanted to fill the next word, then that word supposed to be interpreted from the long-term word that is studying in Spain. So if you have such memory of long word, then only you can able to fill that gap. So these facilities are not there earlier. That is the reason the long short-term memory having such features. So here also I have the working mechanism of long short-term memory. Since we have only 25 minutes more, I will be having more focus and discussions of transformer. But since I want, why you have actually brought the flow in this way is we should know how basically know why we are currently all the generative AI models are relying on transformer. Why not the earlier model? What is the problem? That clarity we supposed to know. In that aspect, I brought this flow. So this is basically the four gates of long short-term memory. One is to store long-term information. One is to store short-term. So again, it is a small neural network with assumed weight, and we will be doing that the long-term memory workload separately and in between, and short-term memory. So finally, we will be basically predicting these results. So in online, we can see that the same text generation could be done using LSTM also. So here I show the final result. Say for example, these are all the sentences are given. India and Pakistan, I wanted to predict the next words. And President Trump, I wanted to predict the next word. And United States wanted to predict the next word. You can see the results at the bottom. So what basically this is nothing but text generation. So now the conclusion is yes, we have done a text generation earlier. It is not new in the generative AI, only in the LLM, only using transformer. No, even the earlier neural network also we have done that. But still, what we have facing the issue is if you wanted to store the long-term information, then we need a more memory, as well as still the even the long-term informations are stored, how long it is, and we are not achieved at the expected results in the text generations. So we are thinking of moving for the alternative. Before alternative, first in 2017, almost some 8 years back, we have seen one paper published. Attention is all you need with the transformer architecture. So here the neural network, which we are very aware of it, and the softmax function. So many components are we are already aware of it. But the unique things that are specific here is something is called as attention mechanism. So now we need to closely look at and closely observe the word attention mechanism, because that is the one we can think of incorporating on already existing or already available solutions. So there are already available solutions. Still, that solutions are not much satisfied. What term I will be telling is there are papers are already published related to text related tasks. Say for example, handwritten recognition, or the sculpture image handwritten recognition. So you can take any such already published work. You can see the result, and without changing any logic, any objective, you just think of whether if you are bringing attention mechanism into that, how basically the results are. In that way, we have a scope to do the lot of research from the already published ideas. So since I hope it is a fifth day, since it is a generative AI, definitely many of them discussed about the architecture of the transformer, encoder portion, decoder portion, and all the individual components. And but I will be taking very specific before I can go for the. I will be very specific to very three thing only as related to text aspect. One is embedding, how basically embedding is done here, and how basically the encoding done here, positional encoding, and what is the mechanism of attention will pay or give an impact in the text generations. I will be going to talk only for these three. And so this is basically the transformer. If you wanted to do a translation, of course we can do, or if you wanted to do a generation, we can do. So basically the encoder and decoder, set of encoder, a set of decoder is the structure. And each encoder, if you take, we have a two component. One is a self attention mechanism, another one is a feed forward neural network. So before I can go for that, as I told, there will be a primary focus of the bottom things. If you look at that transformer architecture from the bottom, any input that's supposed to be first converted to a number, that is embedding, then it has to add it with some positional encoding number, then it will be feed into the attention mechanism. So when I wanted to look at in that aspect, again, the same example of text generation. So the left hand side, I have a set of dialogue and I wanted to complete that dialogue with the right hand side. So how I'm basically going to do. So since I have 5 examples, I will be taking a first example. When you play the games of throne, so what is the expected thing we wanted to fill it is you win or you die. That is the text which we wanted to fill it. But as we know that any text cannot be taken as such by the any computer, it is completely a math. So we need the number for it. So basically, we'll call it as a matrices. And when I can say number, we have a many way to do the number. That is what we have seen. So as per the vocabulary size, I can see an individual number having some unique numbers are called as indices. And if you take in that way, fine. You can take the corresponding indices number. But what we have missed here is, as I told, that semantic features will be missed if you are going with the encoding number. So what we are expected is even we need all the semantic relationship. So what we wanted to do that semantic relationship, the only approach is going for embedding. When I can say embedding, what basically the embedding is, we need to come up with some of the linguistic features, and that's supposed to be appended for all the word. As here we have focus on play game of the throne when you, then for each word, since we have taken the unique number, fine, but each unique number, each words are having, say for example, here only 5 features are taken. For that particular feature, what is that value for that particular word that's supposed to be filled, that will give a clarity of something is called as a semantic relationship. Say for example, if you are taking 512 features, for all 512 features, you can see for every word having number. So this is how we can see that even if we are machine learning model, deep learning model, basically you are dealing with the data. When you can see the data, text data, numbers, image data, numbers, everything is supposed to be number, and that we are aware of it. So because of since if I wanted to show R 512, then it will be very big. So to do some small computations, I have taken only some 5 for visual aspect. So now what I wanted to do is I have taken the 5 linguistic feature of the word play and the word game. And I wanted to see that whether these two words are semantically similar word, not a similar word, semantically how close the words are. And so when I wanted to see, then as per the dimension, this is very important. We will be using the word is called as a multi-dimension. Here the individual values are called as one dimension. So basically we have a 5 dimension. When you relate this word with the real time, it means in the computer we will be using a dimension, 1 dimension, 2 dimension, multi-dimension. We can visualize 1 dimension, we can visualize 2 dimension, we can visualize 3 dimension. That is what we are currently doing. And we cannot visualize 4th dimension. When you wanted to visualize the 4th dimension, then the 4th dimension is the time. You can see many movies related to time travel. Time travel is basically a 4th dimension. And if you could be able to go for the dimension, then you can go for the past as well as you can go for the future. Whether it is possible or not, even I don't know. I have watched many time travel movie. From the time and I have watched many time travel movie, and even I have watched some news about some in Tiruvannamalai, many gurus are flying or traveling. Suddenly they are disappearing. So many such things are heard through news. So it is rather than going with the topic, basically what we are visualizing as a time. So even I have read some information about the fifth dimension, sixth dimension, seventh dimension. I don't know really, but what I read in that article is the seventh dimension Lord Vishnu is there, eighth dimension Lord Shiva is there. So we don't know, but that's how the dimension we can see as the human aspect. But for a computer, the dimension is this. It's a 5 dimension. The previous one is 512 dimensions. In 512 dimension, we can see the word where it is. So in the color aspect, say for example, the play game with respect to the feature, if we're having this color, if we have another word is called as a caterpillar. When you can compare this color, when we can see these two are somewhat similar, not with respect to the caterpillar. So this is how this is actually not the. So here we have a value of play. Then we have to take the value of game also. Then we can see that the how close they are. So this is how we will be visualizing the values. So the same thing, the all the words are come up with the embedding, then we can see that how close are there in the visual aspect. So now what we have done is individual words are tokenized and each tokens are assigned with some embedding. So the next process as per the architecture of the transformer is positional encoding. So you have a word, right? But what is their position? So whether the position of the words having play any role? Yes, of course. Before that, when you can see a embedding, the embedding words are processed by LSTM in the sequential manner, one after another. And but in the transformer, it will be processed in the parallel manner. All the words are taken at a time. When it is taking all the data at a time, then what about that the impact of the positions? So when I can say a position, say for example, you can look at this two sentences. Even though she said she did not win the award, she was satisfied. So the other word, even though she did win the award, she was not satisfied. The position of the word not after the fifth word, the position of the not after that before the last word, that is completely different in the sentence. So now the conclusion is, even though we have these words, what is the position of that word? That is very, very important. And the position of this word is completely changing the sentence. And only even though she did is the word is given to us. If you are rephrasing this and this somehow with respect to the available backup corpus or your learned data, then completely you have messed up with the results because what you in one way you are conveying that in the positive way, other way conveying in the negative way. So both are possible. With that, what that clarity is, the position of the word is very important. So what we are going to do, we are going to add the position information along with the embedding data. So when we wanted to add a position information along with the embedding data, so what is the position values are? We have to give some values, right? It's supposed to be some number also for this case also. What basically the number, if you are giving a number like 0, 1, 2, 3, then what if the size, say for example here 30, if it is 30,000, 30 lakhs, then it is a huge numerical number to be added. So that is not the right approach. Then what is the alternative approach? If you are looking with some proportional approach like this, you are giving a value of this based on the number of words, 1 divided by n minus 1. So this word is given 0 and this word 1, 2, 3. Then if you are giving value like this, then when you are differing with respect to the word, the first sentence you are 4 words, second sentence you are 5 words, then the values will change. So with that, the idea is for previous, based on the number of words, the previous situation you have given one number, the next situation you have given the position with some other number. It should not be. So the value should not be changed with respect to the number of words. Again, the number with respect to the real number or natural number is also not applicable approach, or some approach like this proportional approach also not acceptable. So then the paper itself, 2017, they have proposed what value is supposed to give. So they have come up with these two formulas, sine and cos, and related to sinusoidal wave. So what the important aspect of this is, if you are having a word, say for example, the position 0 and position 6 look like in this aspect the same. But if you are extending further or increasing the value of the I, you can see that these two are not similar. So in that aspect, we will be come up with the position value for individual embedding. And again, here we have a two function. For add number of word, we have one function, and even number of word, we have another function. So in that aspect, we will be fill up the positional information. So finally, we got the result. This is how we can see the positional encoding result. So we have the position values, and we have the corresponding word and the position number, and that only will be embedded along with your individual embedding will be added with the position. So finally, you will be end up with the position and embedding result. So now, what is the next objective is the attention mechanism. So now I will with that I will be taking only the specific portions of a transformer, not all. But this is the point which I wanted to highlight here. What is basically a self-attention? Say, for example, as per this sentence, the animal did not cross the street because it was too tired. The animal did not cross the street because it was too wide. So now the question is the word it is associated with animal, then the next expected word should be tired. 1 minute. Hello. Hello. கொடுத்துட்டு போயிட்டாங்களே சார். சார் வீட்டுக்கு வாங்க சார். காலிங் பெல் அடிங்க, காலிங் பெல் அடிங்க. Okay. So say for example, this is what very important thing, attention mechanism. When we are giving attention to the word animal, then the next predicted word should be tired. When we are giving the attention for this it with respect to street, then we will be having the next predicted word should be wide. So this is what basically the attention mechanism. And we are not giving or come up with the results only by one attention. But as per the paper, we have 8 attention mechanism that you can see here. I can show that. You can see 8 attention mechanism. So 1, 2, 3, 4, 5, 6, 7, 8. So the it word will compute the attention mechanism for all the word available in the sentence, and where it can feel that more number of weightage for that word, accordingly the next word will be predicted. So now for the interpretation perspective, here the colors are indicating. So where we have more brighter color, more number of time, then more number of time, it means more number of attention. First attention, second attention, third attention, all the attention it is having brighter color. Then that word will be having more attention for this scenario and compared to the other word. So this is how we will be predicting the next word. And this is the important mechanism that are bring it into the transformer. So here with the multiple source, I have even brought that the further process of it inside the encoder as well as the decoder. So now once the encoder followed by decoder done, the final important thing is any word, again, it will be converted, the input given as a word, Then after all the computations with a number, again we have to get the result again as a word. So then finally the two important component of the transformer, the softmax, it has to give the based on the probability what would be the word I wanted to suggest from the vocabulary. So this is how we can get that. If what is the word is the input, then what is the probability value will be given more for that word. Accordingly, it has to come up with the text as the output. So here the 93% of the probability for this word and 80% for am. Third one is a. So I am a student. Then it will be ended. So I am a student, that will be ended. I am a student, that will be ended. It means I can see the text here. So the input also I have given the text. In between, all the computations are dealing with respect to number only. So coming to that, the conclusion is yes, currently the same text generations where we started with the probabilistic approach followed by neural network and currently a transformer based approach. We have many tools in the market. If we go for many online material, I can see I have listed a couple of tools to do the text generation from GPT-2, and even we have a GPT-4 now, and how it is basically evolved and where it is collected all the data, what are all the tasks it will do. So with the results, I can highlight it all. Likewise, the Open Train Transformer Language Model and their OPT and paper. And here the important thing what we wanted to do is where they have collected all the data, whether it is a reliable source or not, that informations are highlighted as per the tool aspect for Llama 3. And so this is the one statistics which I have taken long back, but that time itself, I can see that as per the Hugging Face is the concern, the number of models are available in the market. So here I have highlighted the number. So almost each page I can see some 30 models, and I have closer to 4,435. Probably it is increased like 7,000 or not. So that itself I can see 1,33,050 models. So this is how I can see the research articles also. Any new things comes, we are try to adopt. So one thing we missed is we should not. So what I wanted to look at is we can take the applications that we have already applied LSTM, GRU, and or even RNN also related to text, and we can collect all the articles or any specific application articles, and we tried to incorporate the transformer model. And even if there are topics are already incorporated with the transformer model, then we can again further come down and look at still what else is there or where we can give further contributions. So in that aspect, we can look at, I felt. So basically, I will be doing in that way only. And I have done diffusion models for text, and now the diffusion models are done using transformer. So the articles which I have published are using machine learning models, and in between the other researchers are done the same objective with the deep learning model. Now I can see the papers by using the transformer model. So the application is same, objective is same, but the mechanisms are different. So that is the one way I could see that how we are, how fast we are incorporating any new technology comes. So the next thing I can visualize that whatever we have done as of now with a traditional computer, we are expected to do in the quantum machines. So now we are having only the uh, way to do that using circuit methods. But going forward, we will run all our results in the real quantum machines itself. So that's what as the part of my discussions. So I'll just quickly summarize. I have taken with narrowed applications of in generative AI towards text data, especially we have many applications, only a text generation. How basically the text generation done in the earlier days and how the text generations are done under generative AI, and where we can see many models related to that for the same task. So I have taken all the resources from many blogs and many research articles and many YouTube videos and many books. And I have listed all the references here for your uh, further references. So with that, I will be signing off my today's session at exactly 7:30. So before we can go for Q&A session, I
Yes.
once again thank for the coordinators and organizing team to giving me this opportunity. So
Thank you,
now
sir. Thank you.
I'll go for Q&A.
Yes, thank you so much, sir. Participants, now you can raise your questions if any. If there is any questions, you can raise your hands or you can also post a message in the chat box.
So related to this slide, which I have already shared with the organizing team, you can make use of it and will be helpful, I hope.
Yeah, any questions from the participant side?
Vamsi Krishna, thank you, sir. Thank you so much.
Yeah, if you have any questions, you can raise your hands so that we can give you opportunity to ask. Or else you can also post a message in the chat box. Everyone is saying thanks. So I don't think so they have any doubts. Then
Fine, because I even practically I can see their conditions also almost a Friday evening. They are having a couple of weekend plans. So thank you so much,
no,
and
let's consider in the other side, sir. They are very clear about your talk.
uh,
That might be the reason. Yes.
so thank you
Uh,
so much, and yes, as I can see that a lot of informations or materials are there on internet, and what basically the speaker like we can do is we can how the same thing can be taught to informed to them. It is not even taught, informed to them in the
yes.
very quicker way of understanding. That's what I can see,
Yeah,
because
true,
we
sir.
have a sources and we can learn it, but how easily we are conveying that so that the further they can expand from that. That's what I can see.
Yeah, true, sir. So as per your talk, we understand that you have, as you said, you have correctly connected the things. Where to start, how to proceed, and where to end up, and what is the current, and everything you have clearly delivered. So, to summarize, sir has given a comprehensive talk on text generation in Gen AI. He is emphasizing its critical role in NLP, and he clearly started with how the machines can understand for that machines can understand only the numbers, so that's why we are converting the text token we are converting the text by performing the text tokenization, and then we are converting it to numerical form using various techniques like one not encoding, indexing, or embedding. And he also given a significant focus on subword tokenization methods like byte pair encoding, word piece, sequence, like sentence piece, which manage large vocabularies and handle rare words effectively. He also traced the evolution of text generation models from early probabilistic approach to neural networks like RNNs and LSTMs, and finally he ended up with the transformer-based models. And he correctly connected why the transformer-based models are very much important nowadays because of its parallel processing and long-range contextual understanding. He also explained how transformers use word embeddings to capture the semantic relationships and rely on positional encoding to preserve the word order. And the most important part of transformers, namely the self-attention mechanism, which is actually the central to transformers, which allow the models to determine which words are contextually relevant, and the multi-attention aids. And he also mentioned about various tools like Llama 2. He also concluded by stressing the need to understand the foundational models as innovations in Gen AI build upon these earlier methods, forming a continuous cycle of technological processes. And you also end up with where to proceed, mainly in the quantum machines, using the quantum machines. So it was really a wonderful talk, sir, and it was really an informative one, so that they can easily kickstart and proceed with their research. Thank you, sir. Thank you once again for your
Thank you,
time
ma'am,
and
Aglandeshwari ma'am and Anita ma'am.
your
Thank you so much
presentation.
for your
Uh,
continuous.
Adding with
Uh,
Agila ma'am, I am also very much happy to hear your session once again, sir. And it was a extraordinary talk regarding this text generation, that too with the concept of education-based techniques.
Yes,
Thank you very much, sir.
thank you,
So
thank you, thank you.
participants, I hope that they are not having any doubts. So any materials,
which means
whatever
they are
you
also
shared,
enjoying the session.
Yeah,
Yes.
whatever the materials you shared, we will share to our participants.
yeah. Thank you.
Thank you, sir.
Thank you, sir. Participants, please hold on. So you will be having the next session in a minute.